So I've been telling you that for today, we are going to cover halogen compounds and we are concentrating on alkyl halides because that's what the syllabus urges us to do. And I will explain why that is chosen. So we are going to begin with our course outline as usual. Then from the course outline, we shall pick today's lesson targets. So we are going to begin with the course outline. I also remember telling you that the course outline for all organic compounds is the same. For all organic compounds is the same, and it's what we shall be following every time we are handling stuff. So you all know that in these things, we always begin with first things first, the introduction. The introduction. So you may be like, what do we really handle in the introduction? So in the introduction, we handle the functional group. After handling the functional group, we shall handle the classes if the exists. Areas want you to go and find out some of the sources. Areas want you to go and find out about the occurrence. Then not to forget the general formula. Classes sometimes, like for this very case of alkyl halides, we can have classes. We can also have types. For me, I can call them formats and etc. That's always part of the introduction, so you be ready. We shall share those learning outcomes. Then two, after that introduction, we always go to the nomenclature. You always know we go into nomenclature in a very funny way. And this is what usually takes most of our time. Let me see those who have been attending with me since day one and have been following. What usually comes after structure and nomenclature? If you've been with me and you've been following very well, what usually comes after structure and nomenclature? You've introduced things very well. You've learned how these structures are sketched. You've learned how names are derived at. What usually comes after structure and nomenclature? What do we usually talk about? Isomerism, yes. Very good. Very good. So that person usually follows. Yes. We always hint about the isomerism before we go any further. Isomerism was introduced in alkenes very well in the introduction to organic chemistry. So if you have issues, please visit. Yeah. I'm going to tell you the good news after this course outline, and all of you are going to be shocked. You're going to be shocked. So after having isomerism, we talk about the physical properties, and you all know how these physical properties are handled. We are going to be using the same formats. You know how the physical properties are handled. So physical properties. Then 5. After those physical properties, we are always forced to talk about the laboratory preparations, which are not even part of the curriculum, but you know I give you the hints. Which hints we find in further topics, or which preparations, or which hints were talked about in earlier topics, as you're going to see. Laboratory what? How can tell me what usually comes after laboratory preparations? This is the same course outline for all homologous series, and it's what we've been using. It's what we used in alkenes, it's what we used in alkenes, it's what we used in alkynes, it's what we used in benzene. Here we are and we are using it on alkyl halides. What usually comes after that? It's of course laboratory preparations of alkyl halides. Anyone who is telling me anything? Chemical properties, yes. After properties, what do we end with? After properties, what are those two things that come last? This would be chemical properties. Chemical properties. Then, of course, chemical properties of alkyl halides. So at the end, this is where we always look at the application, or what people call uses. So someone tell me, what do we usually have at 0.7? Yes, you need these things. You need these things. The moment you be organized, you know what a topic must have. It is even easier for you to revise. So when you to revise alkyl halides, you just come to this and ask yourself, which are those numbers? I don't know. It's what you read. Maybe if you have a test of alkyl halides. So whatever we always do is very important. That's why we always endeavor to follow it. So applications, what you people call uses. Yes. They always sometimes call them roles. Yes. Of course also the alkyl halides. And I told you the moment they talk of roles, the moment they talk of uses, the moment they talk of applications, they are talking of daily life. So never forget that. So let you always think around daily life. So it is always application in daily life. Has anyone told me what we should put on 0.7? Let me see, do people have ideas? Mechanisms and conversions. Mechanisms and conversions, those things of synthesis, they are combined. We combine laboratory preparations and chemical properties to come up with synthetic problems and mechanisms. That's where those things are. Boiling point, they're under physical properties. But you people have forgotten. I think someone has it. I saw someone writing the word test, and that is it. That person has been following. There's what they call identification of the functional group. That's what we usually do. Yeah. So at 0.7, we shall talk of the identification of the functional group. And I don't usually teach this. I always refer you to a certain video, which we are going to locate again. So it's identification. It's identification of the functional group, of course, of alkyl halides. Yes, functional group of alkyl halides. So people trust me, when all that is done, that's how we come up with the end of the topic. End of the topic. And you all know we always use this first lesson to cover everything you're seeing on the screen. So whatever you're seeing on the screen, we are supposed to complete today. Today. Apart from one thing, that is 0.6 chemical properties. That is special. And we always handle it in a special way. Special way. So stay tuned. Let's introduce. It's always the introduction and isomerism that takes time. But when we finish those, things are very easy. You don't need to worry about that. Okay. I think now we can begin officially. Before I proceed, have it in mind that halogen compounds, it is a senior 5 topic. It's a senior 5 topic. But I want to shock you and tell you that most of the senior 6 topics I got done. So before we even proceed, with the general overview. You know, before we begin any lesson, I should give you a plan so that you have a sense of direction as far as your progress in the subject and revision is concerned. So when I come to the syllabus, let's see what the syllabus book urges us to do. Yeah, I told you I have my own, which is student friendly. Don't forget to invite your friends. These are free classes they must enjoy. Wednesday, it will be strictly premium students. So I wouldn't want anyone to miss free classes. Okay. Now, subtopic, it is subtopic 6.3 and it is senior 5 term 3 work. So it is a senior 5 topic. You listen. Structure, I've talked about it. Nomenclature, I've talked about it. Physical properties, I've talked about them. That's what the syllabus wants. But we are including isomerism because I know it's part of structure. The occurrences, sources, those are just good to know. You need to know those things. Of course, you cannot know functional group without. You cannot know the structure without knowing the functional group. So don't be like, but you've included a lot of things which are not here. But what I've included is needed for you to understand what is here. Simple as that. So the second will be chemical properties, of which chemical properties you all know are the same as chemical reactions and their reaction mechanisms. So it is the same. This is just a visual map. That shouldn't scare you. I'll tell you what it means. Okay? So those two are the same. Yeah? They are talking of reactions, strictly reactions. Then you all know that these are always just things. These are things I don't do. It is always your research work. Because these are things you just use the internet. Because I love giving you a lot of examples, the types, the classes, the nomenclature. So using the internet becomes so easy for you because you actually know whose impact you're looking for. You know whose role you're looking for in the industry. You know whose ethical considerations you're looking for, something like that. So it becomes easy. So realize the backbone of this topic is literally the chemical reactions. This is a very hard topic. Yes, we may need 2 lessons for chemical properties. Serious lessons for you to master them. Because this topic is the backbone of chemistry. Most reactions come from this topic. Yes. So you need to be extra careful and extra attentive as we cover this work. So you can see for the syllabus, we are good to go. So these last ones of roles, industrial impact and everything, for me, I consider them to be under applications and everything. Because as something is being applied, you need to know the ethical considerations. But here, just use internet, yeah? Because even textbooks have less of this content. Yeah. It's a competence-based curriculum, so you need to visit all sources of information. I think that is done. Now, someone may be like, what were the other topics? So that was 6.3. So we have 6.2, which was hydrocarbons. It was alkanes, alkenes, and alkynes. Oh, these ones were done. If you have any issues, it is a senior 5 term 2 topic. You go to the drive and check for that work. There was 6.1, which was the introduction. We were following these very things to cover that work. We came here and looked at each and everything, one by one. So that introduction we also covered. It was also done. It is organic chemistry that is that one branch we have given time and it is very organized on our drive. Yes, all this work. In case you have issues with any of that, I told you to be taking screenshots. This is my syllabus book that I don't give out. So you need to use that chance and take screenshots and keep them. Yes. So if you need to have a look at that work, I've told you what to do. I've given you a solution. But just know yourself. That's what I can say. Okay, now, something small here. So I don't know if people can see my screen. Those who have the drive, I request when you go to the principal chemistry folder, go to senior 5. After senior 5, go to term 2. After term 2, go to Organic Chemistry 1, Part 1. After that, if you want introduction, you go there. It has 2 lessons, Lesson 1 and Lesson 2. Lesson 1 was for general introduction. Lesson 2 was for the terminologies. Every terminology you see in organic chemistry, it was covered there. Then when you go back, alkenes, I think we had 4 classes. There were 3, sorry. So you go and visit them. Lesson 1, 2, and 3 if you have issues. Then alkenes, there were also 2 lessons. You also visit them. You know what lesson 1 is for, and lesson 2, you know what it has. Then you also had alkynes, and there were also 2 classes divided into 2 as I've explained. So those ones were also done. So if you have any issues with them, please do the needful. Now what we are covering right now is term 3 work, and it is the very first topic, and that is the alkyl halide. So when I come here in senior 5 term 3 work, hope people are seeing my screen. You can see organic chemistry. It is still organic chemistry 1, but this is part 2. We have halogen compounds or the alkyl halides, and it's what we are doing right now. So before today ends, we shall have our video there for lesson 1. Then, for us, what we did last holiday, we covered benzene and methylbenzene first before halogen compounds, for reasons that I gave you. So if you have issues with benzene and methylbenzene, please go and visit those 2 lessons, 1 and 2. We are just remaining with only 1 lesson to cover 90% of benzene and methylbenzene, which we are doing soon. So I've just decided to go back to alkyl halides first before I can continue with what? With benzene. Hope people get. And that's where organic chemistry of senior 5 stops. The rest of the organic chemistry is in senior 6, and I completed it before you came back. So those who want to complete organic chemistry this holiday, it is completely possible for you. Even if your school has not even reached alkynes, that means for you are going to complete, and you can. But you need to be this person who is going to revise it every time and every time, every time and every time. So for senior 6, you go to senior 6 folder. Term 1, we have organic chemistry 2, where we have alkyls and phenols, carbonyl compounds, carboxylic acids and their derivatives. So under alkyls and phenols, we have there, the lesson is there. You can check, it is there ready for you. Then under carbonyl compounds, we have there 3 lessons. They are there ready for you. The introduction, the one for addition reactions, and the one for condensation reactions. And I will include all these ones on the timetable so that I find you time for covering this work. I don't want you to say I didn't give you time. Okay. Then carboxylic acids and their derivatives. Lesson 1 for carboxylic acids alone. Lesson 2 for esters, which are the derivatives of carboxylic acids. And that's how organic chemistry 2 ends. Then the next organic chemistry is in senior 6 term 2. And I also completed it. Senior 6 term 2 work. You go to, term 3. Senior 6 term 2, we don't have organic. We only have electrochemistry and periodicity 2. And to make matters worse, also periodicity 2, I covered for you work of group 14. The work is there, 4 lessons. You also have group 17. You can see 2 lessons ready for you. But I'll tell you more about that when I'm teaching in organic chemistry. I don't know if it is tomorrow or Wednesday. Then, so when I go to senior 6 term 3, my interest is organic chemistry. Organic chemistry 3, it is the last one. It has amines and polymerization. So amines, the lesson is there. 1 lesson and amines are completed. Then the other one is polymerization, which is the last one. That one I'll tell you when I'll cover it. But I left it for a very good reason. I'll tell you why. So maybe before people watch these classes, I'll put for you 30 minutes lessons. Only 30 minutes, telling you, introducing you to amines. Yes, they were introduced and everything, but just to give you that vibe for you to start on covering them. And I will surely do that. Yes, so the work is too much to do this holiday. You have a lot of work. I don't know. I invested my time when you people were at school and I covered this work on my own with a few students, very lousy ones, as you hear. But we managed to cover some work. So you need to make your personal timetable. Complete the work by January. You will enjoy senior 6. You'll just be looking for my number to thank me and buy me chicken. Be like, doctor, you really saved us. Thank you so much. Even those who will misfire our questions, you'll be like, at least doctor tried his level best. The misfiring part was my fault. So that is it. So I've given you a plan for organic chemistry. So I don't expect anyone to lack a plan for organic chemistry. It is done from A up to Z. You wait for that of physical chemistry and you will see fire. Yeah, so that is it, people. So let's introduce the topic. Finally. Hope people have taken the screenshot. So introduction, we need to know what alkyl means, what halide means, why they are calling them halogen compounds, and so on and so forth. Are the things we need to know. Yeah. Alkyl halides. So introduction. Okay, now we have said the topic is basically called halogen compounds. That is it. Halogen compounds. But before I even tell you what halogen compounds are, you need to know that the halogens are these ones. You need to know this, that the halogens are these ones. You need to know what they are. I want you to recall something. That the halogens we have, I want you to listen. The halogens we have are what? Chlorine, bromine, iodine. Someone may be like, what of fluorine? Yes, fluorine is there, but we don't usually use it in organic chemistry for reasons you learn in group 17 elements. You learn everything from there. So those are the halogens. Someone may be like, why are they those ones? They are the ones in group 7. And you looked at this in O level, eh? Group 7 written like that. Or sometimes they say group 17, like in your curriculum. Eh? It's not called group 7, but it is called group 17, which is very okay. There are those ones. F2, you first leave it meanwhile. When these ones react with other elements, I don't know whether you people remember senior 1 work, elements, compounds, and everything, and mixtures. They told you that elements, those ones are on their own. They're existing on their own. Then mixtures, you're adding things physically. You're not forming any chemical compound. Then for compounds, things are combining chemically. So you're forming something, you're forming a chemical substance, but the other ones are physically combined. So you're not forming any chemical substance. So when they combine with other elements, what you get is what they call a halogen compound. Yes. After these halogens combining with other elements, what they form is what we call the halogen what? Compounds. And you need to know if it is Cl, the halogen compound, you all know what the one we form is what they call the chloride. You understand? Maybe if chlorine reacts with sodium, what you form is sodium chloride. Maybe if the halogen participating is Br2, the compound we form is a bromide. I want you to follow. If it's iodine reacting, the compound it's supposed to give us cyanide. You get? So what are we really saying here? We are saying that when they react, that's what they form. Yes, form chloride, form bromide, and so on and so forth. Now, because of this, it is similar. Yes. So these first three are what they call halogens. And when you look at this, the ide at the end of everything, that's why you come up and say that halogens generally give us what we call halides. So I don't want you to be this chemistry student who cannot say something about why the name is called halides, especially those who are going to do pharmacy, especially those who are going to specialize in pharmacology, even those who are going to do petroleum engineering, the physics students. If you cannot name these things very well, you cannot become a very good petroleum engineer. Any engineering course that involves chemistry, you must understand nomenclature of these organic compounds. That's why I really give this introduction time, so that you don't be those struggling university students. Get the point? So those are the halogens when they react. Those are the kinds of compounds they form. And generally, we shall say that halogens are going into halides. So you should know that. So when I say alkyl halides, at least people now are aware that it is alkyl halide because at one point, one of the halogens reacted with some funny organic compound or whatever to form the alkyl halide. Something like that, you should know. But I've briefed you well about what halogen compounds are. Period. I'll go back here. I'm going to use this space. I'm getting back. Now, for example, that has been generated. For example, if I'm having my chlorine and I react it, remember I'm dealing with organic chemistry. So I'll bring my methane. So you all know that this one is what? Methane. Isn't it? And you all know this reaction usually takes place in presence of UV light. Hope people are aware of that. That this usually happens in presence of UV light when those two react. So this is our halogen. It's reacting with methane in presence of UV light. And what we expect to form is the halogen compound, as we've said. But you all know that here we consider the product that is gotten when chlorine is limited. And I remember giving you an explanation why, and I'm not repeating that. So you all know that this methane, you all know that this methane looks like this. It is having those four hydrogens like that. So when chlorine comes in place, this H is replaced by one of this H by the Cl. One of the hydrogens is replaced by the Cl. I remember telling you that. So this one takes over. And when you condense everything, you come up with this structure CH3Cl. This is the product you form. Hope people recall this. Hope people recall that. Okay. So when you look at this, I want to remind you or remind us that this CH3, you all know that it's what we call the methyl group. Methyl group, and you all know when chlorine reacts, what you form is a chloride. Isn't it what we said? So you people, just like the way you come up and say that Na is sodium, and because chlorine reacted to form this compound, we expect the compound to be a chloride. And that's why we say sodium chloride. It is the same thing here. Same thing. That since this one is a methyl group and chlorine reacted to give us what we are seeing, you can have that as methyl chloride. It's a weird name and it's not very common. And you may not see it anywhere. But I want to just teach you something. But you come across it in textbooks and at higher levels of studying. Because you may be confused and be like, but doctor, you told us we are forming chlorides, bromides, and everything. Why don't you mention them at one point? This is another way of naming that many of you do not know. Many of you. But hope you know why. This one I've told you it is sodium chloride. So if you want to name something like CH3Br, the same way you named sodium chloride, you'll be like, this is a methyl group. So you say methyl bromide. Because we believe bromine reacted with something to come up with that. And when bromine reacts, the halogen compound that comes out must be a bromide. People know that. However, there is what they call the IPAC system of nomenclature. IPAC system of nomenclature. So I'm going to put X on this, X on provided you're naming it as bromide. I'll put X on that. So what is the IPAC name? IPAC name. The IPAC name is very easy. Because we said, how was the other one named? I remember in functional groups I told you that Cl alone is called a chloro group. I don't know if people are aware. Hey, I don't know if people are aware. I remember teaching you that. I don't know if people recall that. Sorry. I don't know if people recall that. I taught it in benzene, chloro group, bromo group, things like that. So when you're having something like this is our CH3. I'm going to write it like this, CH3Br. You all know how those things come about. Maybe you have CH3Cl. Maybe you're having CH3, the I. Why am I writing them like that? I want to expose this bond. I remember teaching you this very well in the introduction. If you've been with me since day one, these are things that are not supposed to confuse you. And you can also see it clearly here. When I was replacing the H with the Cl here, you should be in position to see it. Are you seeing that we are having 3 hydrogens, 1, 2, 3, with the C, then that bond that is touching the Cl, so it shouldn't confuse you. So that Cl becomes like a side chain, or a group, or a side group. I told you all those things. So I told you, since you're dealing with halogens, remember the Cl2 was the halogen. So when it becomes finally a group, we call it halo group. And by halo group, the first one, bromo group, this one, chloro group, then this one, iodo group. Iodo group. I don't know if these were explained, but I remember talking about them. So have them in mind. Yeah. But when it is Cl2, it is chlorine. When it is I2, it is iodine. Br2, it is bromine. The moment it touches itself to anything else, it now becomes a group. Br, bromo group, Cl, chloro group, I, iodo group. And we collectively call them halo groups. That's if you want. So you can collectively call them halo groups because they are coming from halogens. So which words do I want you to understand? Halogen, halo, halide, bromo, chloro, iodo, halogen compounds. Now we are going to alkyl halides finally. You understand? You're going to alkyl halides finally. And I'll go back to the first page to use this space that I left. Hope you've not forgotten that I'm supposed to use that space. Okay. Now, back to these structures. We said that when it is like this, the other name you can call it is methyl chloride. Remember telling you methyl chloride, isn't it? Then if it's maybe like this, CH2 like that, you all know that this is what they call the ethyl group, this one. You all know it is the ethyl group. Maybe it is having Br like that. So it can be called ethyl bromide Someone may be like, but doctor, are those ones two words or it's one word? For you, what are you saying? I think you can easily distinguish between two words and one word. But just like I was writing sodium chloride and the potassium bromide and everything, it is okay. But remember, this is not IPAC. And I'm also going to warn you. I'm going to warn you about that. So you all know this one is not IPAC. But in case you come across it as you're reading, don't be surprised. Okay, now I remember telling you that these ones halides. Then as you can see, these ones here, the methyl and ethyl, are what they call alkyl groups. Alkyl groups. And guess what? The moment an alkyl group is in touch with one of those atoms, those are what we call alkyl halides. So I want you to be knowing why they are called alkyl halides. And I'm going to tell you the kind of scenario that can be set from just this story I've just told you. I came across it, so I thought it wise that this is very important. And I also tell you. Yes, I think someone wants to say something. Yes. Then out of the blue, your hands are down. Yes, Ben. As if you have a question.
Yes, sir.
Yes, ask.
I thought the ethyl bromide is supposed to be CH3, CH2, then the bromo group.
Yeah, you're right.
But you wrote different one.
Yeah, I've seen. Thank you so much. That's so nice if people are following. Thank you, Ben. Okay, now that is it. So why I really wanted to give you that sort of story, it came in one of the scenarios. Yes, that I'll share with time. They wanted you to use three structures to explain, yes, very well, and after present, why is it literally the name alkyl halides, and why is the sister ignored, and the sister I'm also going to tell you about them. So it's alkyl halides for reasons I've given you, that you can have an alkane like methane reacting with chlorine in presence of UV light. So you find yourself having the alkyl group, the methyl ethyl, being attached to the chloroiodo and so on groups. And when those two react, what we form are what they call halides. And these halides are the same as halogen compounds. So you explain how alkyl groups come about and everything. How do they come about? We have realized one of the hydrogens of the alkane has been replaced by the ClBrOi. I explain those things in alkanes. So please you revisit in case something is not clear. So that is something small about what alkyl groups are. We are going to reach the nomenclature. I've told you that this is not IPAC. So when they ask for the IPAC name and you write methyl chloride, they're going to cross your work. You write ethyl bromide, they are going to cross your work. Why I've given you those common names? Those are what they call common names but not IPAC names. Why? So that the thing alkyl halides comes out. Alkyl for alkyl group. Halide showing that before we had the halogen reacting to form the halogen compound. As simple as that. The nomenclature is going to come. Okay, now, 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 what has been realized? What has been realized? What has been realized? Hmm. What does this mean? Meaning, um, meaning, most alkyl halides have a structure Rx, like that. Have a structure Rx. So what I want to talk about here, what is the R and what is the X? Listen. So the X is the Cl, the X can be the Br, the X can be the I. I want you to listen. And since I've put there X, so it's only one atom. It's only one atom substituting. It's only one atom substituting. Someone may be like, what do you mean by substituting? Remember we talked of ClIBr, substituting one of the hydrogens of the alkane. Then we said that this R is going to be our alkyl group. Going to be our alkyl group. I want you to listen. Alkyl group, you know, it can be the methyl group. Alkyl group can be the ethyl group. If you have issues with these things of ethyl, methyl groups, go to the introduction of organic chemistry. You will thank me later. Ethyl group, methyl group, etc. There are others. But at your level, we always basically concentrate on that. Okay, now I want to ask people. So I want you to understand that since here we are having only one atom being substituted, I don't want you to be confused when you find the name monosubstituted alkyl halides. Don't want you to be confused when you find the name monosubstituted alkyl halides. It is simple, that we have simply only and only. You get? Only and only. One Cl has replaced one hydrogen. So this monosubstitution goes to one, eh? Only one. Yes, the mono part means only one. Alkyl halides, I think you can see the alkyl groups, how they are going to attach the chloro group, the bromo group, the iodo group, the ones they collectively call halo groups. So when you see the structure Rx anywhere, I don't want you to be confused. I don't want you to be confused at all. At all. I don't. Okay, now, need to understand. What if we go beyond monosubstitution? Yes, what if we go beyond monosubstitution? Like, for example, we have our methane. Yes, methane will help us learn others. Maybe like, why methane every time? It is the simplest alkane, so it can help us understand others. So you all know that this is how methane looks like. This is H. Then this side you're having H. Then here you're having H. Then here you're having H. That's how methane looks like. So you all know monosubstitution, we replace only one. So when we replace only one, we shall have our C with 3 hydrogens and maybe one Cl, like that. That is when only one has been replaced. I want you to follow. Then what if we replace 2 of them? Yes, we also get a second one, and so we are replacing this and this. So we shall have been left with 1 carbon, 2 hydrogens, and then the remaining 2 hydrogens have been replaced by 2 Cls, like that, isn't it? What if 3 of them? What if? That means we are also getting the third. We are saying, what if we go beyond monosubstitution? So now the third is also going. That means we have been left with 1 carbon, 1 hydrogen, and 3 Cls. Like that, because 3 things have been what? Have been replaced. What if we go ahead and we replace all of them, all the 4? And that means we are also coming to this one, and we are giving it away. We are losing it. What is going to happen? Yes, we have our carbon. We have no hydrogen, but we are having 4 Cls this time round, replacing all of them. So here we are only one. Remember what we are forming. Whatever we are forming is a halide. Hope you know that. Halide, which can be chloride, bromide, iodide. I explained all that. So here we are only one has been replaced. This is what they call monohalide. Mono because of one mono, halide. One word. Monohalide, it is the same as saying just halide. Just like you people say, instead of saying 1x, you can just say x like that. You'd be like, it's a repetition. 1x and x are the same. So monohalide and halide, we assume they are what? They are the same. And in this case, it is a chloride. When two of them have replaced two hydrogens, this is what they call a dihalide. I want you to follow. When three of them, one word, have replaced three hydrogens, that's what they call a what? Trihalide. When four of them have done the replacements, this is what they call a what? Tetrahalide. Yes. Tetrahalide. Tetra for four, tri for three, di for two, like that. And I don't want you to be surprised. You people have heard of monomers, you people have heard of polymers. You get the point? You've heard of those things. So don't be surprised when they tell you that, oh, those three, they are what they call polyhalides. 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 Just like you see from monomers, we have polymers. So from monohalides or halides, we have what we call polyhalides. So I've said polyhalides. Sometimes they tell you even a dihalide is a polyhalide. Sometimes they tell you that for polyhalides, it's only the tetra and the tri. But you should be ready for anything. But that's just English. There is no chemistry there. So because of chloride, you just replace. So in the case above, it's a chloride. So in the above case, what do I want you to do? I want you to replace halide. So halide, cancel it out. And then put what? Chloride. What do I mean? Monochloride, chloride. Dichloride, trichloride, tetrachloride. That's why this one is called carbon tetrachloride, carbon trichloride, carbon dichloride, methyl chloride, like that. So what is this all about? The possible substitutions. And why trichloride, tetra, di, and mono-X is it, and how? You okay? Now, I want to take you back to dihalides a bit. Before I even go to other things. Or before I go to dihalides, allow me to talk about something small. And it is the what if part. What if? What if? Do we still have 80 people? Hey, people 90. Thank you for following. Thank you for following. Thank you for following and thank you for the audience. What if? The people who will watch these videos in the future, they should be proud of you for giving me audience and not making me shout. Yes, they will be so proud of you. That's why we are supposed to be serious and focused so that we give a very good picture to the future. So what if? What if? What if? What if? What if? What if in Rx? What if in Rx? What if in Rx? R is a phenyl group. Who can tell me what does a phenyl group mean? What do I mean by phenyl group? People have been talking of alkyl group and so on and so forth. But what if R is a phenyl group? Yes, Justus. What is that phenyl group?
It is when it is attached to a benzene ring.
Yes. I remember telling you in benzene when I was teaching it that a phenyl group is a benzene ring acting as a side chain. Phenyl group, benzene ring acting as is a benzene ring acting as a side chain. I told you that. That's what they call a phenyl group. That's what they call a phenyl group. That's what they call a phenyl group. That is to say, you all know what X is. Something like that. Something like that. Those who have been following the naming, you will also enjoy this. Because if you know that this is CH3Br, and I told you that this one is locally methyl bromide, you can tell that this one is phenyl chloride, phenyl bromide, phenyl iodide. That when you find or come across them, you're not surprised. But I myself in benzene, I told you that the name of this, the IPAC, I told you that is not IPAC. I told you that the IPAC is chloro what? Benzene. I told you that the IPAC is what? Bromo benzene. I told you that the IPAC is iodo benzene. Remember telling you that. Chlorobenzene, bromobenzene, iodobenzene. I told you that. So someone tell me, if at all the R is a benzene ring, which is called a phenyl group, are they really still called alkyl halides? Hmm? Hmm? Are they still alkyl halides? You either say yes or no, but when you say no, tell me what they are. Are they still alkyl halides? This is the only thing I want you to learn today. Yeah, if you learn this, you can log off. If you learn that, you can log off. You'll be very safe. Chemistry will not be your problem. If at all this R is not, let me see what people are saying in the chat. They are saying no. You people have said, I've said when you say no, you tell me what it is. When you say yes, it is okay. I'm asking, if at all the R becomes a benzene ring, what we call a phenyl group, and I've told you the nomenclature, the common names and the IPAC, I've told you both. I told you I speak more than I write. So you either supposed to listen carefully and write at a very high speed, like that. Yeah, I'm seeing people have ideas. Which is very good. So, people, this alkyl is for only alkyl groups, the methyl, ethyl, propyl, isopropyl, butyl, terbutyl, tatbutyl, and so on. The moment we go to the benzene ring, it's a phenyl group. Those who attended the lesson of benzene, I remember telling you these things very well. I told you that benzene belongs to a family called arenes. And I told you that's why they are called aromatic compounds. You get aromatic compounds. So, they are called. So the answer is no. No. They are not alkyl halides. What are they? They are aryl. I don't know why, but when I use capital letters, things become hard. I don't know if people can see that. Aryl. Aryl halides. Someone may be like, why are they really called this? Why aryl? Where does it even come from? It's simply because they are aromatic what? Compounds. Then those of you who attended introduction with me, I remember telling you that aromatic compounds are those ones that have a benzene ring somewhere. Yes. So those compounds with a benzene ring somewhere, and those compounds with a benzene ring somewhere and have the halo groups, the chlorobromo and iodo, they are aryl halide, not alkyl halides. Why aryl? Because they are aromatic compounds. Why are they aromatic compounds? They have a benzene ring somewhere in their structure. So in their halides, they are aryl halides. So you can see aromatic, aromatic, aryl, aryl, aromatic, aryl, aromatic, aryl. So they are not alkyl halides. Hope you've learned that today. Yes. So you people, hope you are now aware what your syllabus meant. That's what the syllabus meant. So in most of the reactions I will concentrate on, you may not see me using aryl halides. So I don't want you to be like, Doctor, why aren't you talking about the aryl halides? I'll be following the syllabus. It said halogen compound, then in brackets it said alkyl halides, meaning that the aryl halides may not be so necessary unless a student just goes an extra mile. Maybe because we even find them in benzene. They just didn't want us to do some sort of repetition, which is very okay. So I'm going to go back to the introduction and use the other space and tell you what everything meant. So on the very first page, it is the second. So halogen compounds are basically two. We have alkyl halides. So this is where I had to start from, which you are supposed to cover. Then the other ones are the aryl, which we are not supposed to cover. Why? Maybe they wanted us to reserve it for benzene. Reserved for benzene. And benzene falls under a topic called aromaticity, the study of aromatic compounds. Yeah, like that. Like that, reserved for aromaticity. Aryl halides, other one, alkyl halides. Okay. So people, hope that introduction is okay. Hope you know why we are looking at alkyl. Hope you know what aryl are and everything. So this is the stem of the discussion. Whatever I've been discussing or whatever I've been teaching, you're free to forget. You can forget whatever I've said, but don't risk to forget what I'm about to write. Yes, what I'm putting here next is very paramount. Yes, especially if you want to join engineering school, if you want to join medical school, if you want to join School of Food Science and Technology, if you want to join and all other schools, just listen to this carefully. So that is about R being a benzene ring, which is the same as a phenyl group. Now, what if, these things have classes. So I've already told you that formats. The formats are those things of dihalides, trihalides, tetrahalides, and so on. Now, I want to pose a question. About dihalides, they can occupy the same carbon So dihalides, we always mean that they're two X's. You understand? We have X and X. X and X, you all know. In the example we had, it was Cl2. Two X's, what I can call X2, like that. So I'm saying that they can either occupy the same carbon, I'm going to show you what I mean, or different carbons. They can occupy what? The same carbon or different carbons. I'm going to put here an example, Ig. And I'm also going to put here an example, Ig. If you're having this chain, and also this chain, by same carbon, for example, coming here, then I put my Cl, then I also put here my Cl. By different carbon, I mean, I put here Cl, and another Cl goes there. You get? Then I put my hydrogens elsewhere. You all know the balance is always taken up by hydrogen. This carbon had a balance of 3, this one had no balance. This carbon has a balance of 2, this one has a balance of 2, this one has a balance of 2, like that. You know, if people are following, here the two Cls, the two X's, it can be Br or anything, they are on the same carbon, this one. Then here they are on different carbons. One Cl is on this carbon, the other Cl is on this carbon. I don't know if you're seeing that. Hey. Now, if you're to condense, those who have been with me for some time, you know what I mean by condensing. So to condense, I'll put here the first carbon has 3 hydrogens, so it is CH3. The middle carbon has no hydrogen, so I'll say C. So I'll write the C. Then I write the Cl2 as well. Have C, then also Cl2. Then the last carbon has CH3. I don't know if you can see that. So that's how we condense. Then if I'm also to condense this, what will I have? Have CH2, the carbon has 2 hydrogens. So having Cl, then this carbon in the middle is having 2 hydrogens, so CH2. Then the last carbon is also having 2 hydrogens with the Cl. That's if you're to condense. But you could also expose the bonds, which is not so necessary. Always teach yourselves to condense, apart from those cases where we emphasize not condensing. Are we together? Okay, now my point of emphasis is on this. The carbons being, one carbon having both halo groups. Then also when separate carbons have the halo groups, these things have names. You all are aware that this one is called a dihalide. We all know that the first one is a dihalide because the X's are 2 or the Cls are 2. Even this one is also a dihalide. It's also a dihalide. Why dihalide? Because still they are 2. But where is the difference? The difference is that for the first one, they're on the same carbon. For the second one, they're on different carbons, as you can see. So, I don't know which format we are going to use, but you people are not supposed to forget this, because they are one of the things that make you a very good chemist. Very good chemist. Very good chemist. Okay. Now, I'm going to put towards here. I think we are going to do some sort of matching. Maybe it may help. Maybe it may help or not. So people, sorry for that. I've been on a call. Sorry for that. I usually don't pick calls, but there are calls that you're already supposed to pick. Yeah. Okay, now, where are we? What was I saying? Let me check in the chat. What was I saying? So that I can connect. But the other one has to be in adjacent carbon atoms. Of course, it has to be. Hey, people already giving me answers. Hey. People are saying Gemino. Gemino does not exist in chemistry. Yeah, matching stuff. I had asked for matching. Okay. Okay. Now, someone gave us a very important thing to note. Said that, but the other ones are supposed to be in adjacent. Yes, but that's not what I was going to write. But maybe I'll give that to people as research. There's some research I'm going to give you. I'll also make this one part. I wanted to teach you all the three cases at once so that you be good chemistry students. But someone has mentioned something so important. Let's maybe consider it. Okay. So let's choose the Cl to be here. Adjacent, yeah? Someone talked of adjacent carbons. Very good. Seems people here are good readers. Adjacent meaning they are near to each other. Eh? So those two carbons, adjacent. So that means this last carbon is having 3 of them. So I'll come to this last one. I'll come to this last one and say CH3. Then I also come here, instead of CH2, I will have the H and the Cl. CH, Cl, then at last I'll have the CH3. Like that. Why am I doing that? I just want us to respect the fact that the Cl and Cl, yes, they're on different carbons, but those carbons are adjacent and they are here in red. You can just see that this carbon is adjacent to this carbon. So this first one is having that Cl, the second one is having that Cl. I think you can get that. Now we have two types. We are having two types of dihalides. And I want us to do some sort of matching, but our matching is going to have research. We have the dihalides we call gemino. So those who have been typing gemino, I don't know where you got it from. I don't really support it. I've not read that before. They are either called the gemino or vicino. Gemino or vicino dihalides. So we are supposed to identify. We are supposed to identify which one is the gemino, which one is the vicino, like that. I want you to go to the internet right now. You ask Google or AI, ask it, what does gemino mean? Or where does the word gemino come from? You see, in chemistry, most of the words, for you to understand them, you should first understand, why was it really called gemino? Where does this word come from? Especially in organic chemistry. Most of the names of things, we shall see that as we proceed or as we progress in inorganic chemistry. Go to the internet and ask, where does the word gemino come from? Where does the word gemino come from and the meaning? You tell me the meaning in the chat. I remember I used the internet last year for that. And I remember it gave me a very serious response that enabled me to recall. But these are things that used to give me a time back then. But with time, we solved everything. So, what does gemino mean? What does gemino mean? It comes from the Latin word that means twin or paired. Exactly. Is it what everyone is getting from the internet? Nina, yours is very okay. It comes from a Latin word that means twin or paired. The word gemino. No, not gemino. Gemino. It is gemino. You people, it is gemino. I've told you gemino is for biology. It's the relationship between two functional groups on the same carbon atom. You're not asking what I told you to ask. You people are very bad. I told you to ask where the word gemino comes from. Yes, blessed soul, thank you. The word gemino comes from the Latin word gemini, meaning twins. So think of it like twin halogens on one carbon. Now someone is just searching gemino. I say gemino, not ja. It's of a Latin origin meaning twin or pair. So that is enough. Thank you. So the word gemino comes from the word Gemini, which means twin. You get? So you people, of the first structure and the second structure, where do we have twins? Where do we have twins? They talked of twins or something like paired, something like that. Of carbons of chlorines on the same carbons and those on different carbons. Which ones can you put a hand for and say that these are the twins they are meaning? It is the first one. Yes. Two identical groups attached on the same carbon, and it came from the Latin word called Gemini on the same carbon. I think we have understood that. We have over talked about it. Hey. So, this one, the first one, it is the gemino. You people, it is gemino. Gemino dihalide. Then this one, it is what? Vicinal dihalide. Like that. Vicinal dihalide, do not forget that they are what? Adjacent carbons. In chemistry, don't cram definitions. Understand what things mean and period. No one is going to tell you to define what a geminal dihalide is, what a vicinal dihalide is. No one. So don't stress. Get the point? So that is all. And I'm going to wrap this off. Yes. So hope that is okay. Considering the geminal and vicinal. That shouldn't disturb you. Those words can be used in so many scenarios and on so many occasions. So you should understand what they mean. Yeah. So we have said geminal comes from a Latin word, Gemini, which means twins or paired, like that. Yeah, so that's why we take it as that. So when you see two halo groups on the same carbon, geminal dihalide. When they're on different carbons, but those different carbons are adjacent, vicinal, like that, and period. Now, let's conclude the introduction. I told you when the introduction is done, the other things are easy if you've been following me up. The other things are easy. So, I remember teaching you something about primary, secondary, and tertiary. Here I am to repeat those things. I want you to listen. You're more than 80 people, and I want you to listen. I want you to leave this place when your kings and queens of primary, secondary, and tertiary, quaternary and everything, sort of alkyl halides. Because that's one thing that makes you feel the chemistry. Because there are so many arguments around them. So if you're this one chemistry student who can stand on their feet and be like, no, this is this and this. Not students who say that's what the teacher said. A student who can come up and say, no, why are you arguing? Gemini and vicinal is something you're supposed to forget for the whole of next term and master it in third term. So you must be this kind of student who in arguments you'll be like, Gemini came from Gemini. It's a Latin word meaning twin or paired. What are you saying? Not these kinds of students say, let me bring my chemistry book. Why did you bring your book? Bring evidence from your head. Period. So, most importantly, is about the classes. Most importantly, classes. Most importantly, classes. Hey, you people have showed you the graphical structures. The graphical structures are those structures where I expose the bonds. I told you that in introduction. So most importantly, they are the classes. They are the classes of alkyl halides. I want you to listen to this. I want you to listen extra carefully. Question. Who determines the class? Who can raise up your hand? You tell me and I give you some money. Who determines the class? Who determines the class of alkyl halides? Who can tell me? I give you some money. Judith was the first one to raise up their hand. You tell me, Judith, who determines the class of alkyl halides?
I think it's the halogen, the halogen and the carbon atom on which it is attached, and the number of hydrogen it has.
Do you have an MTN number?
No, sir, I haven't yet.
You have one Airtel. That is absurd. Okay, you read it. Do you have it there? That is a very good answer. Very perfect. It's even better than mine.
Pardon, sir?
You don't know the number?
I don't know. It's 07 47 62
52
62
62
68
68
21.
21. Okay. You stay on. I don't want people to say I didn't give you cash. You read it again.
07 47
8 what?
62 68 21.
Do you have it there?
Yes, it's the one I'm using.
It's bringing Janet.
Yes.
Hey. Have you seen the money? Don't tell these people the amount. They will be jealous. Have you seen it?
Yes, sir. Thank you.
Don't tell these people the amount. They will be jealous because someone may inbox here and tell you give me some 100K out of that. So thank you for that beautiful answer. So don't give them your money. Yeah, she gave a very good answer. She said that what is going to determine is first and foremost the carbon. Which carbon? The carbon that is having the halogen atom. And what exactly is determining is the number of hydrogen touching that carbon. That's a very good answer. Very perfect. So who determines? It is the carbon. It's the carbon having the halogen atom. What do I mean? That one carbon atom that will have the Cl, that one carbon atom that will have the Br, that one carbon atom that will have the I. It will depending on the structure. It will always depend, and I'm going to show you how. So the moment you realize that one carbon touching the halogen atom, that carbon touching the halogen atom, that carbon touching the halogen atom, it is that carbon that will determine the class. So the question is, how? 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 How does it determine? So we now know who. How? How? Yes, we know it's the one determining, but how? Okay. So we are going to say when that carbon atom which one? This one. The one having the Br, the one having the Cl, the one having the I. When that carbon atom has, I want you to listen, 1, 2 hydrogens. Let me say, when that carbon atom has 3 or 2 hydrogens, 3 or 2 hydrogens. When that carbon atom has 1 hydrogen, then there is also when that carbon has 0 hydrogen. 0 hydrogen, there I mean no what? No hydrogen, like that. So it is very simple. When it's having 3 or 2 hydrogen, that's what they call the primary what? Alkyl halide. Primary alkyl halide. And you all know primary, they represent it with 1 knot. If not 1 knot, they write 1 superscript RY. That's how they write primary in science. Alkyl halide. If it's having only and only 1 hydrogen attached to it, of course, that one is what they call the what? The secondary alkyl halide. The secondary alkyl halide. And then when it has no hydrogen, completely no hydrogen, that's what they mean, or that's what they call tertiary. This spelling usually disturbs people. People use double L, I don't know why, but it is what? That. I've emphasized it, so I don't expect people to make errors. Tertiary, tertiary in chemistry. So it's like that. So for secondary, just like primary, if they don't use 2 power 0, they use like that. Even tertiary, when they don't use 3 like that, they do this. Because all end in RY, like that. That's what they usually do in science. But someone may be like, how do you know it has 2 hydrogens? How do you know it has 1 hydrogen? I'm seeing someone called Richard is marking our work. Thank you, Richard. You can even comment. So that is it, people. Who determines the class? The carbon having the Cl or Br or I. And how does it do it? We depend on the hydrogens attached to it. So I'm going to be putting here a very simple word that I've been forgetting. 3 or 2 hydrogens attached to it. One hydrogen attached to it. No hydrogen attached to it. Understand? Hope people are on the same page. So you people, I want you to first tell me about the class. This is most important. You can forget everything. It's okay. Even what I told you to recall. At this point, you're free to forget. But don't ever forget about how classes are determined. Don't forget that. So before I even put down the structures, first tell me about that. Take a screenshot and even put it on your status. Don't fear students seeing you that you're reading. You read hard and pass, and shame all of them. This is a very good profile picture for anyone academic about the classes. Very correct work. Very correct work. So I want you to first go through who determines and how they determine before I put for you the structures below and you tell me which classes they are. We are going to be using letter P for primary, letter S for secondary, and letter T for tertiary. So what I'm putting down, they are going to be structures, and it is you people to tell me that that structure is tertiary, that one is primary, the other is secondary, like that. Yes, and I'm happy that that people these days are enduring and they are persevering, because we are around 90 people. People are in 88. Hope people are not dozing. Let me hope people are not dozing. We are candidates. We have our time. Let's use it well and do the necessary. If they're okay, you'll be like good to go. If you have something to ask, you ask it. And I just want 5 people to tell me good to go, good to go. I put the structures. We say their classes using letter P, S, and T. We go to the next thing. Yes, I don't want us to waste a lot of time. You just type good to go, good to go, good to go, good to go, good to go. Most are tired. That means some people are dozing. Anyway, it's okay. Anyway, a candidate gets the audacity to doze. Have something to ask. Raise up your hand. Where are you? Someone had something to ask. Yes, all of you are going to unmute and ask. I've asked you to unmute. Yes, I'm listening to you all.
Me Evans. I'm asking, as you're determining the primary, secondary, and tertiary, I thought we use a number of alkyl groups attached to the carbon atom that has the halogen. I'm asking.
Yeah, I'm going to respond to that. Another one?
Teacher, I'm called at class Acrod. Yeah, even me, I was like in alcohols, we use the number of alkyl groups attached to the carbon atom. So I don't know if here it can't be considered.
I'm also going to answer you. Another one, and I'm liking that. Another one.
Okay. Am I on?
Yes, Josam. Yes, speak.
My question is, initially when the type of class, what I knew is you consider the carbon with the halogen, but then its position in the carbon chain. So if it's the halogens are on the second carbon, that's secondary. If they are on the first carbon, that's primary. Then for the tertiary, what we knew is that same one, a carbon without any hydrogen, that's tertiary. That's what I knew. So I need you to help me rectify that.
It is the same thing, by the way. It's the same thing, but I know what people want, and I'm going to rectify it. Hey, people have a lot of questions. Yes, the next, I've asked you all to unmute, those who are asking. So the first one?
You know what I'm asking is that
when
I'm having a carbon atom, like I'm having 3 carbon atoms, and the last one is having 2 groups which are not hydrogen. Is it a secondary or?
I'm going to rectify that also. Another one? Sudai, so blessed soul, you speak.
Excuse me, sir.
Yes, Sudais.
So I was asking that what does the 1 degree, the 2 degree, and 3 degree represent?
Hey, 1 degree primary, 2 degree secondary, 3 degree tertiary. I don't know why Glory is writing in our screen. I don't know. Glory, what's wrong? Are you menstruating? Yes, I think the last person is Blessing. Then I proceed. Yes, Blessing.
Teacher, me, I think for you to determine whether something is primary, secondary, or tertiary, you depend on the number of hydrogen atoms attached to the carbon that has the halogen.
And that's what I've said, isn't it?
Yes.
But people want to know why their ideas are partially correct, but they are okay. So those people were asking me, I'm going to put for you here 2 halogen compounds. Then you tell me which class they are. The first one I'm putting is this. And the next I'm putting is this. So you've said that we should depend on the number of alkyl groups that are attached to the carbon that has the Cl, Br or I, isn't it? But realize when we look at this one, it is CH3 with the Cl. You understand? That this is the very carbon that has the Cl. And it has no carbon attached. So it's like you're meaning that it has no, like it's neither primary, secondary, or tertiary. You know that you people are getting me. Your reasons are okay, but they are limited. That's why they are not what? Highly recommended. They're okay. They are correct for some compounds, but not all. Like for this compound, the reason of the alkyl group doesn't work. I don't want you to say, but it is here 1 methyl group. No. You said the alkyl group attached to the carbon, which carbon has the functional group or the Cl, or what I generally call the X. I told you when I say X, I mean Cl, I mean Br, I mean I. So when you look at CH3Cl, the carbon that is touching the Cl is actually the very carbon of the methyl group. So like there are no other alkyl groups. So it's like you're meaning that this one has no class, which is not right. That is one. Second, when I go to this second structure, you look at it. I remember teaching you these alicyclic compounds in the introduction, and I told you that each of these corners are carbon compounds. Sorry, carbon atoms, Carbon atom there, carbon atom here, carbon atom here, carbon atom here, carbon atom here. And we all know that carbon atoms are what? Are very comfortable with 4 bonds. And in that circle, each carbon has 2 bonds. What do I mean? Look here. One carbon is having 1 bond, 2 bonds. Even this one is having 1 bond and 2 bonds. Even this one is having 1 bond and 2 bonds. You understand? Like that, because they are in a ring. So I want you to listen. So that means that this one is having 2 hydrogens, even this one is having 2 hydrogens, even this one 2 hydrogens, even this one 2 hydrogens, even this one 2 hydrogens. But this carbon must have 2 hydrogens, but one of them was already replaced by a Cl, so for it has only 1. Because when you give it 2 hydrogens, it will have 5 bonds, which are too much, because carbon accommodates a maximum of 4 bonds. So I will remove that. It's not supposed to be there. But why am I doing that? This compound is also, it is okay to call it a halogen, it's okay to call it a halogen alkane or haloalkane. It is very okay. I remember telling you that alkyl halide comes from alkane. And also this one comes, of which alkanes, there are those they call cycloalkanes. So it exists. So when you look at this, what are you really going to do? We don't have any alcohol group here. It's not here. Where is it? I cannot see the methyl, I cannot see the ethyl, I cannot see the isopropyl, I cannot see the propyl, I cannot see the tert-butyl. They are not there. It is just a ring. But if at all I use the reasoning of hydrogen atoms, it really works for me. You get? So those people with the reasons of alkyl groups, I think you see they are limited to some compounds, but of course not all. Now if I'm to draw another one, it will work. Yes, it will work very well. But the reason is limited. So the best answer is that of the hydrogen attached to the carbon, that the very carbon which has the Cl, Br, or I. So using the reasoning that we know, you can realize that this first structure, chloromethane, before I even go to the nomenclature, the carbon having the Cl is having 3 hydrogens. So these 3 hydrogens make it what? Primary. So it is a primary what? Alkyl halide. When I go to this structure, this one, I'm going to teach you the names, don't worry. I'm going to teach you the names. When I go to this structure, the carbon that has the Cl or Br or I is here. And I've told it's having only and only one hydrogen. So because it's having only and only one hydrogen, we call it what? Secondary. So I think you see that this one is easier, where you just look at how many hydrogens does the carbon having the functional group have. And that is all. So are we good to go? I put my numbers, especially those people who had questions. Those of you who didn't have questions, don't say anything. I want these people who had their concerns. Have your concerns been addressed? Have your concerns been addressed? Should I put my 6 or 8 structures we give their classes and let that slide? Okay. So someone else had a certain question. That what if there are 2 of them? What if it's a dihalide? I think it was Josam. So Josam, these classes for your level, it's only monohalides. So let's concentrate on monohalides, leave the rest. Remember telling you monohalides, you just ignore and say halides. I have seen someone who has just annoyed me in the chat. The person has said, but sir, most books consider alkyl groups. I don't like that sort of reasoning. If you're really a serious student, I want you to say that, sir, the books of organic chemistry that I used as reference books at your level, the first one is Principles of Organic Chemistry by Murray. All those books are there on the drive. Another book is Modern Organic Chemistry by Waddington. The third book is Brown Organic Chemistry. The writer is Brown. The third one, you can use, if you don't use Murray, Principles of Organic Chemistry, use Modern Organic Chemistry by Waddington, then there is Brown Organic Chemistry. Those are enough. You shouldn't go to the other very heavy books that you don't need. The Morrison and Boyd, the O.P. Tandon, those big books of chemistry, you don't need them. But the ones you need, I don't even want you to go to those books. Textbooks confuse. You don't need them. But if at all you want to visit them, I told you everything is full package. You have all those things, you just don't want to visit a drive. So you just go to the folder of senior 5, senior 5 chemistry, and go here where you see revision and e-library. Then you go to organic chemistry. It's here. If you're seeing my screen as I'm giving you directions. Then you go to organic chemistry textbooks. Then you go, do you see? We have Brown organic, it is there. We have Modern Organic by Waddington. Then we have Principles of Organic Chemistry by Murray. Those are the only books. You go there and check. Don't be those kinds of who say most books. Which books? You mention them. Don't just say most books, say which books. And are they reference books at your level, period? Yes. Students who pass, listen to the teachers they trust and move on. Okay. Someone has asked about carbocations. I advise you to visit the video of introduction where we talked of terminologies. So carbocation was part of the terminologies. So I know you will like it. But it is the same reasoning. So I'm going to have 1, 2, 3. I'm going to have 9 structures. I'm going to have 4. I'm going to have 5. I'm going to have 6. I'm going to have 7. I'm going to have 8. I'm going to have 9. Yeah, they're going to be enough. So the first structure I'm drawing, the first structure is CH3, CH2, Cl. The next structure is like this. CH3, Br. Another structure is CH3, CH, CH3, then I. Another structure, it can have a benzene ring. Let me use called the benzene ring. Then CH2, Cl. Then the other structure you can have is CH3, C, CH3, then also on top CH3, then down have Br. Then the other structure have I here. I want you to prepare answers. I want you to prepare answers. Prepare the answers. And then Okay, we are going to move in this order, huh? 1, 2, 3. So 1, 2, 3. Remember, we are using letters P for primary, S for secondary, T for tertiary. So 1, 2, 3, we are using a 3-letter code as the answer. So I expect answers like PPP, SSS, TTT, PST, PTS, PPS, PPT, PTT, PSS, SPP, STT, SPT, like that, PTS. I don't know. I don't know if people are getting what I want. So 1, 2, 3 is what we are beginning with. I want 10 answers. PTS. PTS. People have passed that. PTS. Yeah, that is good. P, T, S. Very correct. P is correct. T is correct. S is correct. 4, 5, 6. We proceed. 3-letter code. 4, 5, 6. 4, 5, 6. 4, 5, 6. 4, 5, 6. 4, 5, 6. 4, 5, 6. 4, 5, 6. 4, 5, 6. 4, 5, 6. 4, 5, 6. Yeah, people have passed. It is also PTS. It's also PTS. Very correct. Someone may be like, but you people are leaving me. Why are you like that? Okay. For 1, this is the carbon that is touching the Cl and it is having 2 hydrogens. That's what makes it primary. This is the carbon having the Br and it has no hydrogen. That's why we call it tertiary. This is the carbon having the what? The I, and it's having only 1 hydrogen. That's what makes it secondary. Why the second one has no hydrogens? Because each carbon has 2 hydrogens. And the same carbon already has methyl group and Br. That means both hydrogens were replaced and all of them are nowhere to be seen. You get the point? Then the 4th one, this is the carbon having the Cl and it's having 2 hydrogens. That's what makes it primary. Because primary, we say 2 or 3 hydrogens. 5, this is the carbon. Hope people are preparing answers for 7, 8, 9. 7, 8, 9, prepare them. So for 5, that carbon, the one having the Br, has no hydrogen at all. It's only having 3 methyl groups. That's what makes it what? Tertiary. Then this last one, you all know, this is the carbon having the I. And since each carbon in a ring has 2 spaces, 1 space has been occupied, the other remaining space is for the hydrogen. So it has only 1 hydrogen, and that's what makes it what? Secondary. The last one, what is it? It is also PTS, isn't it? Yeah. So don't risk. Don't risk to forget how classes are identified if you really want to pass chemistry. It is the same thing we shall say with alcohols. It is the same thing we said with carbocations. Just don't forget. Yes, that the carbon, someone may be like, but how is this carbon touching the Cl? I told you how these structures are made naked. expose the two hydrogens, put one up and one down. You see that the carbon is touching the Cl, and it is also touching these two hydrogens. That makes it primary. This is the carbon having the X, which is in this case Br, and it has no other hydrogen. That's why it is what? Tertiary. Then this carbon having the X, which is in this case I, has only one H, and that's what makes it what? Secondary. Even if they ask you in the paper why, that's the reason you should say. You should just be a good literature student, being in position to convert that into a very correct English statement. Period. That's about identifying classes. Very important. Now, I want to pose a question. Which is so important. What is so special? What is so special about the 9 structures above? What is so special about the 9 structures above? What is so special about the 9 structures above? What is so special about the 9 structures above that makes them different? That makes them different from other structures? That makes them different from other structures? Who can answer that question? Let me expose for you the structures. You see them. They are there, 9 structures. I want you to look at those structures very well. And you look for those things that make them special that other structures maybe don't have in chemistry. I want you to tell me, what is so special? If you look at those structures, what is so special? What is so special about them that other structures don't have? Yes, Akrod. Akrod, did you want to say something about that? What is so special? Yes, please, say it.
I think the special thing there is the functional group, the carbon halogen bond.
Exactly. That is it. Perfect. That's what I wanted. He has said it. That what is so special about those structures that maybe other structures don't have, it is the carbon 2 halogen bond. And this carbon 2 halogen bond is what they call the functional group. That means Akrod has been following the classes well, because I told you that the functional group is that special thing about a certain homologous series that other homologous series don't have. So because it is special about them, that's their functional group. It's the only thing homologous series brag about, because it determines their chemical properties, and chemical properties make them different from others. You understand? So carbon 2 halogen bond, it is what is so special, and it is the functional group generally. But different compounds have different functional groups. So because this word halogen is very big, it's very big. Why? The halogen can be the Cl, the halogen can be the Br, so ClBr, the halogen can be the I. So it depends on the compound, you get? So if maybe I'm going to put here compound, which is specific. So I'll say specific compound. I'll say specific compound. Then here I will say functional group. Get the point? I'll put here my specific compound, then here I will have the what? The functional group. Now the specific compound, it is CH. The specific compound, for example, CH3, CH2, C, like that. So you may be like, what is the functional group here? Maybe like, what is really special here? So I just want you to be that kind of student who can break this down. It's something that used to give us a time those days. Like this one is the same as C, then Cl. Then these other two hydrogens are here. So that special thing about that compound is this bond. So when they ask you for the functional group in this compound, don't say doctor told us carbon to halogen. Here the halogen is specific. It has been specified. That's why I called that a specific compound. So you also have to be specific enough and say the functional group is the carbon to chlorine, because we said halogen, to chlorine bond. Yes, that is the special thing, and that is the functional group. So other people, you're going to help me with these two. You're going to help me with these two. It's not me who's going to say them. It's you to help me with these two. So what if the structure is this? Someone tell me. You people just write this. Just write the functional groups in the chat. Save time. Write the functional group of that very fast. Very fast. You write the one of that. This is what people are saying in the chat. Carbon to bromine. Carbon to bromine. Carbon bromine, that is wrong. Supposed to be carbon 2. Carbon 2. So someone may be like, where is that carbon? The carbon is here. Every corner is a carbon atom. Yeah, so what is special in that compound is the carbon 2. I see people putting hyphens. It's okay. Carbon to bromine bond. Carbon to bromine bond. Very correct. Then this last one, carbon to what? But it's supposed to be bromine. Don't risk and say bromide. You get things wrong. It's supposed to be what? Chlorine, bromine, iodine. And you all know these things. Trust me. Carbon to iodine bond. Iodine, very important. Very important. Now, as usual, you all know that I always give you some research work immediately after we talk about this. And what is always that research work? So it is about the occurrence and sources. Occurrence, and I told you when I say occurrence, I mean their occurrence in what? In nature. Then sources, I told you when I say sources, I mean the natural, I mean the artificial or the synthetic, natural, biological, and of what? Of basically today, alkyl halide. That's what we are handling. Yeah, just read about them. Use the internet. It is okay. Just want to give you real chemistry. That is your research work. Now, I want us to talk about the structures and how they are named. You see, nomenclature is the easiest, and it's what we are going to enjoy in most. Even when it is coming at a very weird hour, but it is not yet midnight. So as a candidate before midnight and it is holiday, it is very normal. As a candidate and it is before midnight, it is very normal. Yeah. So, very first about the structure. Very first about the structure. I want you to listen carefully. Hey, I want you to listen carefully. So it is about structure and IPAC nomenclature. And your name marks IPAC. Yes. Okay. So, I remember telling you, I think we are doing alkenes. We named some of these structures. So trust me, we are not going to oversay it. We're not going to say a lot of things. Most of the things, you know them already. Yeah, and we are simply naming alkyl halides. They are not hard. They are not hard. You've seen most of the structures, so naming them is going to be easy for us. It's going to be easy for us. It's going to be easy for us. And you should recall a lot of things. You should recall a lot of things. Hey, I want you to recall this. Who recalls the 3-letter code I gave you? Who recalls the 3-letter code I gave you in nomenclature? The one we use as we are naming most things. Who recalls it? Who can write it? Who can write it in the chat? But I doubt none of you can. And I know most people have forgotten. But I taught it. Someone recalls it. PSN. That has been my student from day one. Very serious. PSN. PSN. Very important. Very important. Very important. And remember telling you that it applies everywhere, you like it or not. This P is the position of what? Side chain. And what is this name? It is usually the parent alkane name. So this N is for name, yeah? Maybe like E. So that one is for the parent alkane name. This P is usually for position, but position of the what? Of the side chain. This is not so important. You can name even when you don't know PSN. But for me, I just like it for its versatility, in that it applies at so many occasions, and it is always nice. So let's first do first principles and see if it will help us. So you all know that when you get this, which is methane, we come up with this structure. So you all know that this one brings a chloro group. We all know that that one brings a chloro group to methane. Get the point? Hey, should know that the Cl2 brings a chloro group to methane, and that's why we come up with our name, that is chloro what? Chloromethane. A chloromethane. Like that. But using this PSN can also have something. It'd be like, of course, the parent alkane name, alkanes with one carbon, it is methane. Are you listening? Then, of course, in this case, our side chain, side group, or our group is the chloro, that's why we have it. So it is chloromethane. Someone may be like, how is the position? This Cl is on carbon number 1, and it does not have any other carbon it can attach to. So no need of mentioning the position. You only mention the position if it's necessary. But here it's not necessary. I'm not going to over repeat the basics of nomenclature. No, I'm not. I said it all in the introduction. For you to mention position, it should be necessary. How do you know it is necessary? When the Cl maybe can occupy more than one position. But for this case, the Cl can only touch one carbon. There is no other carbon, it is one. So you mentioning the position that one chloro, it's not important. When you say one chloro, that means there is a possibility of having 2 chloro, 3 chloro, and others. But if it is one chloro and there cannot be any other possibility, then the position is not necessary. PSN, chloromethane. So you simply say the chloro group has found its way in methane, so chloromethane. So you leave the methyl chloride. Methyl chloride was there to show us how the word alkyl halide was brought about. But the IPAC name is chloro what? Methane. And it is one word. It is chloromethane and it is one what? One word. So you put that in consideration. It's chloromethane and it is one what? One word. What if it is ethane? What if it is ethane? CH3, CH3, and maybe it is Br2. Good. So just like we have said, Cl2 brought a chloro group to methane. So Br2, this one brings a bromo group. And it is bringing it what? To our ethane. And that's why we are going to call it bromo what? Bromoethane. Yes. And you all know what happens. One of the hydrogens is replaced by what? By the Br. That's why which was H3, it becomes H2, and the other third hydrogen is replaced by what? By the Br. I told you this in alkanes when we are talking at chlorination and bromination, so you can revisit that. Hope we are together there. So, because the Br2 brings a bromo group to ethane, that's why we say bromoethane. But again, someone may be like, but here you're having 2 carbons. Why don't you do something? The problem is one. Let me ask you people. This one can become 2 structures. Yes, the structures can be 2. What do I mean? The first one can be left as CH3 and the Br attaches here to this carbon. You get? Oh, the Br can touch the first carbon like that, CH2, Br, then the other one is left as CH3. You understand? Those are the only two structures we can get. Those are the only two. That the Br either touches the first carbon or the last one. But remember, in nomenclature, we always consider the lowest possible position. That when it touches the first carbon, we are going to follow this direction. And this one is going to be carbon number 1. When it touches the last one, this is going to be the direction we are going to follow. And still this one will be carbon number what? Carbon number 1. So because of the rules of nomenclature, you're not supposed to put anything here. Like the position is not necessary. So in our PSN, the position is not necessary. Because even when we change it, we have done nothing. We are just spoiling things. Nothing has happened. Nothing has been done. So in PSN, please and please ignore the what? Ignore the N, the P, the position, for reasons I've said. The side chain, our side group is the Br, bromo. And this is the name of the parent alkane, which is ethane in this case. I don't know if people are following well. The position is not necessary. How do you find out it is not necessary? Try to change positions and see if there is change of a name. If there is no change of name, not necessary. If the change of name exists as the next example, then it's worth it. Hope people are following. Okay, let's go to another one. So this has been the first one. This has been the first one, A. This has been the second one, B. So now let's handle C. C. So imagine you're having this CH3, this is CH2, this is CH3. You get? And you're adding there your what? Your Cl2. So I want us to have 3 options. There is a possibility of replacing the first hydrogen or one of the hydrogens of the first carbon. So that instead of CH3, we have CH2 and the Cl is there. I taught you how to condense. I'm not going to waste time. Then I'll complete the structure like that. You get? There's a possibility of replacing, or the replacement happening on the second carbon. So that from CH2 we have CH, and then also Cl here. Then lastly we have CH3 like that. Then there is also another possibility. There is also another possibility of replacing the last one. Actually, let me do this. The one of replacing the middle, let me put it here. Then replacing the last one, let me put it here. Replacing the last one, this will be CH2, and will be CH2, then Cl. You get? So if I want, I can put it there. But I taught you how to condense. I can put it here. Condensing, I just paste it at the end. Are you people following? So this time around, we are having a carbon chain that has 3 carbons. So I'm assuming the product we are going to form occupies each of them separately. We want to see what actually happens. In nomenclature, we always consider the lowest possible position. So for this case, when I consider this this direction, where the Cl is touching will be carbon number 1. Hope you get. When I go to the second, considering the lowest possible position, I will have to take this direction so that still I give this carbon position 1, which is the lowest possible. I don't know if people are following. But when I come to this last one, either directions give me a position of 2 for the Cl. So whether I take the left or the right, it is the same thing. So I just take on any direction like that. And this one will be position what? Position 2 like that. So you realize In some compounds, we can have position 1. In others, we can have position 2. And this is where the P comes in. P is for position of the side chain or side group. Because it can have position 1 in some cases and position 2 in some cases. So this time round, it is necessary. Because in the first two structures, it is position 1. Even when it's coming on the first and last, same position 1. Why? In nomenclature, we consider the lowest possible position. But in the last one, we have no option other than position 2. So since positions may differ at one point, mentioning them will be very important. You get? So according to PSN, the side group is chloro, then the parent name of the alkane is propane because it is having 3 carbons. So all these ones are chloropropanes. Why chloropropanes? We are having a chloro group touching itself somewhere in the chain of propane. A chain of propane has 3 carbons. And we are seeing the chloro group finding its way through. It is finding somewhere to sit in the chain of propane. And it is coming as a chloro group. That's why we call it chloropropane. And since it can occupy more than one position, the position will matter. Where it occupies position 1, we call it 1-chloropropane because the chloro group is sitting at carbon number 1 of the propane chain. Where it is sitting on carbon 2, we call it 2-chloropropane. Why? The chloro group is sitting on the second carbon of the propane chain. If you cannot do right nomenclature, you will struggle a lot in chemistry. Just make sure nomenclature is your friend. Make sure you can draw the graphical structures. Make sure you can condense them, and you will enjoy the branch. So, these first ones, or these first 2, we have said they are the same, and I've explained. They are the same. I've told you why we are supposed to mention chloro. Sorry, 1. I've told you why we have to mention the position 1. You know why it is chloro, and you know why it is what? Propane. So the 1 is the position. Our side group, side chain, chloro. The parent name of the involved alkane is propane, PSN. You can just make the first principles your friend without confusing yourself with PSN. But it has helped so many students. That's why I bring it in. Then this last one, it is 2-chloro. Why? The chloro group is on carbon number 2 of propane, or on carbon number 2 of the propane carbon skeleton. 2-chloropropane, 1-chloropropane. As simple as that. As simple as that. And I also remember we said all these things in alkenes. Though in alkenes the side groups were the methyl, ethyl, and so on. But now this time around they are the X's. When I say X, I mean Cl, I mean Br, I mean I. So you should listen carefully. Okay. Now, the next structures you're going to try and name. You're going to try and name. Yes, you're going to try and name. There are those I named in benzene, and those ones were aryl halides, and they are not supposed to be part, so I will not bother myself. But I will be happy if you people go with this at least. Yeah, that one. That one. You write the name. You write the name. You write the name in the chat. You write the name in the chat. 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 I want to see that name. Let me first give you a chance to write. I want to see that name. People are struggling. Hey, people are struggling. People are saying benzene. People are saying benzene. You people, you are not easy. Let me first begin with this. This one is not the same as this. I don't know why. I'm feeling pain when I see people saying benzene. But those two things are not the same. I remember teaching you the benzene ring. I told you how it came about, the struggles that came up, how they came up with the Kekule structure and everything. This one is what they call bromobenzene. Let me help people. People, this is it. Are you seeing this? And this? They are different. This one is benzene. You can just say benzene or you say benzene ring. Why it's called a benzene ring? Because of the ring inside, basically. This one is hexane. Why hexane? It's having 6 carbons. You people know the hexagon. It's a face-sided polygon. Sorry. 6 face-sided polygon or 6-sided polygon. It has 6 faces. So it will be hexane. It will be an alkane. And because of the 6 carbons, it will be hexane. But since those carbons are in a circle, they are forming a cycle. It is cyclo. So we call it cyclohexane. I don't know if you people are understanding. I told the nomenclature of those things in earlier topics. So the benzene ring is very clear. Even the cyclohexane. Why hexane? Because it's the hexagon. It is having only single bonds between those carbon atoms in a ring. That's why it's hexane. Why cyclo? The carbon compounds are arranged into a ring of carbon atoms. So when you get this Br and make it touch the benzene ring, I remember telling you the name becomes bromo what? Bromobenzene. Bromobenzene, and it is one word. Bromobenzene, and it is one what? One word. So I want you people to use common sense. If this was benzene and this was cyclohexane, if this is bromobenzene, then what is this? Just use common sense. I don't want to over-explain about that. Benzene alone was the other one, and the other one was cyclohexane. When I made Br attach benzene, it became bromobenzene. So what is this one? Bromocyclohexane, period. And it is one word. One what? One word. Cyclohexane. I saw people saying it 2 bromo. I saw people saying 1 bromo. And I know they are concerns, and let me address them. But I talked about them earlier. You people, when I come here and I put here BR, then another person comes and puts the BR here. Then another one comes and puts the BR here. I told you these things in benzene because I know they disturb students. These things are the same. This one is the same as that. Even that one is the same as that. What they are doing, they are just merely rotating. They are rotating these things. They just rotate it and the BR comes here. They rotate it again. It goes here. You know, if people are seeing that. They rotate it, it comes here. They rotate the ring again, it goes there. Like that. So no need of you mentioning the position. The moment you mention the position, it is wrong. Some of you have that tendency. You think that this is carbon number one. Who told you that? That is your own thinking. You're like, maybe this one that is pointing up is carbon 1. Never. That rule is nowhere, so you ignore it completely. These are just strings of compounds. You just rotate. So when you rotate, even the BR goes with the rotation. You rotate, it goes with the rotation. You rotate it, it goes with the rotation. Nothing happens. So you shouldn't, that one shouldn't stress you. Hope that is okay. That shouldn't stress you. These rings, they just change. Because bromobenzene will never change. Even if they bring that BR and put it here, it will still be bromobenzene. Because we believe they have just what? Rotated the ring. So nothing has been done. And we are always safe. Okay? So bromocyclohexane. Very nice name. Very nice name. Now, I remember teaching you certain alkanes. I don't know if people recall. But I don't want us to stress so much with those names. But they are nice. Problems come in if people cannot recall. I want you to look at this and tell me the name. What is the name of that? You should even, after us naming this thing, you put it on status. After we have named it perfectly, you put it on your status to hurt your people. Who can name that? Put it in the chat. Put it in the chat. But I want you to learn something. That before it was like this. It was that K1 with the CH3. You understand? Then after they added BR. So when you add BR to UV light, one of the BRs replaces one of the hydrogens, and this one becomes a what? A 2. You get the point? So you need to know what is the name of this first. After knowing the name of that, it becomes easy. Don't you remember we had methane, then BR brought bromo, then we said bromomethane. So first find out what is the name of this. After you knowing the name of that, then remember that this one brings what? Bromo. So we just have bromo this, like that. So any names in the chart? Bromomethyl cyclohexane, exactly. You get that this one alone is cyclohexane. But it has a methyl group, but since that methyl group has no position, it has no position. It has no position because when you rotating it won't change its position. So mentioning it is not necessary. You just have to say that it is methyl cyclohexane. Everyone will understand that the methyl group is somewhere on cyclohexane. Then when BR comes and attaches itself there, to be very important. Just come here and say bromo, methyl, cyclohexane. One word. But these are very rare names. Just like the brain teasers we had in math today morning, these are also just brain teasers. Just understand the other basic nomenclature. We just understand that. Don't worry about these others. After all, the syllabus doesn't talk about aryl halide, so we shall not stress about that. But for me, I usually never risk, because I know chemistry remains chemistry. So research, remember aryl halides are not part of the syllabus, but anything can happen. So research about the nomenclature of aryl halides, but they are not part of the syllabus. Maybe they want you to find them in benzene, because in benzene they are there. But you make research, they are not hard. What is the name of that? Things like that. Those are the two that usually disturb. But they are very easy. Just make research, but they are very easy. I told you whatever I put in research for me, I count it taught. So please, that is extra work. Don't worry, Christine, we are safe. Don't worry. Don't worry. Okay. Now, those are the two. You make research about those aryl halides. Maybe you shall find them in benzene, but you find out they are not hard. Because you know, before this BR came in, we had our phenyl ethane. You get phenyl ethane. This is phenyl, and this is a chain for ethane. Phenyl ethane, phenyl, and this was a chain for ethane. Hey, here it touched. I don't know which carbon you may want to choose. Carbon 1 here. I don't know the carbon you may choose. Hey, very easy thing. But this one usually gives people hard time. Hey, it usually gives people hard time. Think, let me teach it to you. Let me teach it to you. So that you people leave this place when you know it. It is one thing you can enjoy in chemistry. And I want you to listen. Because trust me, you are going to struggle with it. Hey, let me help you. Let me help you. Let me help you. Because I know you will not do this research and it may be serious. So let me do my part. Let us do it together. Please, you people, you leave our screen. So you people, this is it. This is it. You are having ethane like this. This one is what they call ethane. You get the point? We are having two cases. We are having this case and this case. I want you to listen carefully. In this case, or in both cases, In both cases, I want you to follow. In both cases, the phenyl group is touching that carbon. The phenyl group is touching that what? That carbon. In both cases, it is touching that carbon. But the Br is going to different ones. And that's what makes it hard. And that's what makes it hard. Same cases. Okay. In the first case, the Br is going here. But in this other case, the Br is going here. So this carbon is left with 2 hydrogens. This carbon is left with only and only 1 hydrogen like that. Then here this carbon is left with 3 hydrogens. Then here this carbon is left with 1 what? 1 hydrogen like that. Now you all know that a functional group is always given the first priority. I told you that. Functional group is always given the first priority, no matter what. First priority. I told you the functional group is always given first what? First priority. Because it is always given first priority, in this second case, that is carbon number 1. Because that's the carbon with the functional group. And in this case, because the functional group is given first priority, that one becomes carbon number 1 because it is the one having the what? The Br. Now the problems come with the naming. We have identified that the Br, that the ring is at the same carbon, but the Br is on different carbons. And that will affect priority. Because where the Br is, it being the functional group, we shall give it the first priority. Why is it being given first priority? We have said because it is the functional group. Saying all that because it is the functional what? It's the functional group. It's the functional group. Yeah. But now the naming. I want you to listen carefully. Who can try? Because you know that this one is called the phenyl group. This one. Or no, this one is called the phenyl what? Group. And we have already said these 2 carbons, they mean our parent is ethane. You get? Hey. Then also these 2 mean our parent is ethane. And you know that this one is also what? Bromo. Hey. This one, bromo, the 2 carbons mean ethane. 2 carbons mean ethane. We are having a phenyl group. Benzene ring as a side chain. Let's hear from Evans. Let me give you a chance. Yes, Evans.
I'm trying to name the first one. The first one, since you have said that the bromo is taking the first priority because it's a functional group. I can say that because since it's on the first carbon atom of the ethane, I can say that one bromo, one phenyl ethane. That's the first one. The second one, since the bromine again is on the first carbon atom this side, I can say that one bromo, one bromo, 2 phenyl ethane. That's what I think.
Yeah,
Yeah.
that's very good. But let me ask, what have you realized about the position of Br?
The position of Br. Like the position of Br, I think in all cases, since it is ethane, where whichever position it is on the ethane, it will be on the first carbon atom.
It will be on the first carbon atom because it is the functional group and it is the first priority, isn't it?
Yeah.
What if we ignore the position? Do you support it? Because yes, you're right. Because if for the first case, if this is carbon 1, that means this is carbon number 2, isn't it?
Yeah.
Then for the
Yeah.
second case, if that is carbon number 1, this is carbon number 2. And you all know B comes first, then P, isn't it?
Yeah. According to the alphabet.
According to the alphabet. So when I come here, so my parent is ethane. So when I come to mention the side groups, I'll say here we are saying 1 bromo, isn't it? But
Yeah.
even the phenyl is on position 1, so I say 1 phenyl ethane. Not so?
Yeah.
Okay. Then I also come here and say this one will also be, this side, it will also be 1 bromo, but this time round 2 phenyl.
Yes.
This time round 2 phenyl. Then isn't it?
Yes.
But in each case, the position of bromo is 1. What can you say about that? Is it really normal? Should we just look at that?
I
What's
think
your
I think since there is on the second one, since there is this phenyl group, I think it also needs a position. So I'll try to give the bromo group also a position, but I may not be clear.
Yes, it is okay. That's a good try. So this name is okay. This name is okay. But I want to ask you a question. Are you on?
I'm on.
What if I wake up one time and tell you that this one is 1 phenyl? Because I may say, but in either case, the position of bromo is 1 and 1. Let me ignore it and begin with 1 phenyl. Then I say bromoethane. Then here I say that this one, this side, it is 2 phenyl. It is 2 phenyl bromoethane. You get it?
Yeah.
I want to ask you something. And I said that this is 2. Someone may be like, why aren't you saying bromo 2 phenyl? It's not okay. You always begin with a number if it's somewhere. So 2 phenyl bromo ethane. What do you say about those names? Are they wrong? Is this name wrong? Are they wrong? The other one, you're using the basics of nomenclature, which are very okay. But for me, I may come up and tell you that bromoethane, we all know it is like this.
Bromoethane.
A bromoethane, isn't it like that?
Yeah.
And because the BR is attached to this last carbon, we are all aware that, oh, that means this is carbon number 1, isn't it?
Yeah.
So when someone comes and say 1 phenyl bromoethane, they are telling you that on this very carbon atom, that first one, They are like
Yeah.
telling me that on that very carbon, the first one, that's where the phenyl group has decided to come and sit. I don't know if you're getting. But remember, as it comes, it is replacing a hydrogen. So this hydrogen remains one. Then the Br comes back. Isn't that the one phenyl bromoethane?
Yeah, so that
Remember,
is it.
remember this one alone. So this one is the one phenyl bromoethane. Remember this one alone is bromoethane without anything. Are you listening?
Yeah, I'm listening.
So when someone comes and tells you that 2-phenyl bromoethane, you ask yourself, where is my bromoethane? It is here. Where is carbon number 2? Carbon number 2 is here. Just in case. You understand? That
Yeah, I'm
this
trying.
carbon is the one having the Br and my carbon number 2 is this by default. So when you say 2-phenyl, you are telling me that the phenyl group came and replaced one of those hydrogens. So what was CH3 becomes CH2. I don't know if you're getting me.
Yeah.
Then the other one remains as CH2 Br2. Are you getting it? And this is the 2-phenyl bromoethane. So the other nomenclature, the first one we have, is very okay because it brings out the thing. But the only problem is it is having these repeated positions for the bromo, which we can ignore. And when we ignore, the one phenyl must come first, then bromoethane. 2-phenyl comes first, then bromoethane. And I've also tried to write the names first, and you realize the structure actually brings them out. You get? So
Yeah, because either way,
you're supposed to
it's
just be flexible as a chemistry student of organic. Don't cram things. Do them, you see, 1 and 1 coming out, 1 and 2 coming out, then be like, but this is 1 and 1, can't I ignore? And also learn that they don't say bromo 2-phenyl in chemistry. No, supposed to say 2-phenyl bromoethane. If numbers are there, it is okay. But you cannot say iodo 3 chloro. It is the 3 chloro iodo. You understand?
yeah.
So that's why I'd fear to leave this as research work. It would confuse people a lot. But don't worry, these are aryl halides, which are not under the topic we are covering, but we find them in benzene. So it's like we are trying to hit two birds with just a single stone. So don't give up. Don't give up. And hope the people are on you listening. I don't know if people are sober. We may be having here big numbers, but people are dozing. Let me see those who are awake and trying to follow. Maybe and we are only 10 students. If you're on, you say I'm on.
But I'm asking, I'm asking that what if I have maybe, okay, if it was butane, maybe not ethane, yeah? It's not okay. It's not okay. It's not okay to start with bromo.
If what?
Maybe if I'm having butane, like butane instead of ethane, do I follow the
You
basics?
may not for that case.
I have to begin with phenyl again.
I've told you the first ones we have of 1 and 1 and 1 and 2 are correct. I've not said they are wrong. But this is just a coincidence that by default, one compound has 2 names of IPAC, which are correct, and it is a very rare case. That's why when I gave it to you as research, I looked at it and saw 2 alternatives which are correct. So I said, let me go through this. So when you reach those of that are having propane and butane, you will see that the name is only one if you have been following critically. But trust me, this nomenclature is not hard if you have been following. A case in point. Are you seeing this?
Yeah.
This one alone is benzene. The moment I come and add a methyl group like this, I'll remove that hydrogen and put CH3. This one alone is benzene. This one is methyl benzene because I've added that. And no need of positions, because for you to change positions, you just rotate it. So no need of mentioning. That is methyl benzene. Now, on this very CH3, when I get one hydrogen there and I replace it with Br or Cl, maybe this becomes CH2Br. I just understand that the bromo group came and fixed itself on methyl benzene. And that's why I'll call this bromo methyl benzene. One word. Nomenclature is not hard. Now this is the basic nomenclature you need. That one of 2-phenyl, 1-bromo, it shouldn't overstress you. Those are brain teasers. You just need them as you progress. But the first ones I always deal with, prioritize those. Like this one, from cyclohexane to methylcyclohexane to bromomethylcyclohexane, benzene to methylbenzene to bromo to chloromethylbenzene. Single words, no space left. Those are the ones you need. These ones will come with time and as you practice. You get the point?
Yeah.
So, those things are not hard. So before we become less than 50, let me do the last thing, we go. Then we go back and tick the learning outcomes or the lesson targets, because we are done and most of the things have been talked about. Yes, we are done, and thank you for listening. Yeah. So lastly, it is here. You can have your CH3 and by chance, you have this one being replaced and this one being replaced. Hey, you can have that being replaced. So what happens? You may have CH2 and CH2. So this one may be replaced with Br. Also, this one may be replaced with Br. We saw this in alkenes. So for you just look at PSN, period. What is your parent name for the alkane? What are the side chains and what are their positions? Very easy. Here there are two. So we have one Br which is on carbon 1, and we can say this one is on carbon what? Carbon number 2, and there are two of them. And they are sitting on 2 carbon skeletons which make up ethane. So we cannot leave that 1, 2. So you're supposed to come and say 1, 2. And the bromo groups are 2. So after 1, 2, you said dibromo. I don't know if people are getting it. So 1 and 2 dibromo means 2 bromo groups on carbon number 1 and 2. But on whose carbon skeleton? On the carbon skeleton of ethane. One word, don't leave space. And you're done. And you're simply following PSN. PSN, P for the positions 1 and 2. Side chains, meaning the bromo groups are 2 dibromo. They are sitting on a skeleton of 2 carbon atoms, and that is always ethane. Period. Hey, not hard at all. There are very rare cases which they may not even ask you. They may not even ask. But let me do it for fun. Maybe one is replaced by what? Cl, and the other is replaced by Br. Or may I see this as fun? Because this is Cl, another one is Br. So here I just use alphabetical order. A, B, and C. You understand? So that means B must come first before C. So that means where we have B, I can come and say this is my what? My carbon 1 here. This is my carbon what? Carbon 2. Then I say it is 1 bromo, 2 chloroethane. You understand? 1 bromo, 2 chloro, again, 1 bromo, 2 chloroethane. Why ethane? Everything is happening on a carbon skeleton of 2 carbons, which is ethane. I think that is very clear. This is very clear. It's not hard. Now, I want someone who is going to name for us these ones. I want someone who is going to name for us these ones. When there are 3. So you all know this compound. So I'll be ending with this. So you all know this compound. You all know this compound. You all know this compound. Yes. So we can have replacements at the end. There are 3 hydrogens, so we can replace 2 of them and remain with 1 hydrogen. Remain with 1 hydrogen. So this is H. This is Cl. Then here we are having Cl. One is CH2. This one is also Cl. You get? Then we also have CH3, Cl, Cl, CH3. I told you replacements. Then we can have on the first one and the last one. First one can leave this one and also have on the last one like that. Hope people know what we always replace. Then we can also have these ones. This one can be left. That one can be put there. And we can also have one at the end like that. So you all know the hydrogens we are replacing are these ones. We can replace that one and they remain 2. And we can replace both and it remains 1. This one, we can replace 1 and it remains 1H. We can replace both and we don't remain with any H. This one behaves as the first one. So I want us to look at the nomenclature. So the nomenclature is very easy. We prioritize the functional groups. You all know that. So because here the Cl and the Cl are on the same carbon and it is the last one, this is the direction we shall take, this one. Why? So that we prioritize the position number what? Position number 1. Very important. So that we prioritize position number what? Number 1. Because here there are 2 of them on the same carbon, which is the first one, we shall follow that direction. And this one is also carbon number 1 because of the direction. Hope you're listening. Okay. Then this one have no option. When I follow this direction, this will be carbon 1 and this will be carbon 3. When I follow this direction, this will be carbon number 1. This will be carbon number 3. So it's like it's the same. Have no option. Even this one, the same thing. When I follow this direction, this will be carbon number 2. And when I also follow this direction, this one will also be carbon number 2. Then these last ones, this, when I follow this direction, is 2, 3. When I follow this direction. When I follow this direction, it is 1, 2, 3. You get? So I'm supposed to take the direction of the lowest sum. So when I consider this direction in green, it will be 2 plus 3, which is a 5. But when I consider this one in blue, it will be 1 plus 2, which is a 3. So this is a 2 plus 1, which gives me a 3. Then this direction, the one in green, it is a what? It is a 2 plus 3, which is a 5. And you all know that in nomenclature, we always take on the what? We always take on the lowest possible position. So I'll take this direction of 1 and 2. The same thing here. I'll take this direction because it gives me 1 and 2, which is a 3. The other one will give me a 5. It will give me a 2 and a what? A 3, which is a 5, and I will not take it on. This one gives me 1 and 2. This one gives me 2 and 3. That's why I'm leaving it out, but I'm taking on the other one. Hope you're following. Hope you're following. So now things become easy because all of them are on the carbon skeleton of propane. Why propane? We are having 3 carbons throughout. That is why we are having propane, because throughout there are 3 carbons. So the other thing is about the position and the side chain. So the side chains are the chloros, chloro, 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 bromo, 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 anything. So the other last thing we are supposed to do are the positions. So the first one, it is 1 and 1. Even the second one is 1 and 1. So these two are the same. That's the news. These two are the same. Even when the 2 are on the first and last carbons, because of the rules of nomenclature, they are the same. So you're supposed to come and say 1, 1, dichloro. You're not supposed to forget the dichloro. And then they are sitting on a carbon skeleton of 3 carbons. So never forget the 1, 1. Because they are 2 and on the first carbon. And after mentioning 1, 1, di is a must. Dichloro, because there are 2 chloro groups and they are sitting on the carbon skeleton of propane. Period. Then this one. It is 1 and 3 in either directions. So you're supposed to just come and say that this one is 1 and 3. There are also 2 chloro groups. I'll say dichloro. If it is bromo, you also say dibromo. You get the point? Pro what? Propane. One word. Hope you know why it is propane. Hope you know why it is propane. We proceed. This one was 2, 2. So you come and say 2, 2. 2 chloros. So you come and say di what? Dichloro. And what are you getting? Propane. Very correct. Hope you know why it is 2, 2. Hope you know why it is dichloro. Hope you know why it is propane. That's all you need. Then these ones, they are different, but because of the rules of nomenclature, both of them are 1 and 2. 1 and 2, 1 and 2, 1 and 2. So I also come and say these ones are 1 and 2. So I also come and say 1, 2, dichloro, 1, 2, dichloropropane. 1, 2, dichloropropane. Hope you know why it's 1, 2. Hope you know why it's dichloro. Hope you know why it's propane. That's all you need. And when you people look at all those structures, I want you to look at them. When you look at all those structures, all of them are having 3 carbons. All of them are having 3 carbons. All of them are having 3 carbons. All of them are having 6 hydrogens. You count. Leave the propane alone, which has 8. I'm talking of this one. Remember, propane had 8. But in each case, we have been substituting 2 hydrogens with 2 Cls. So all these ones have the same structure. 3 carbons, all of them, 2 Cls, all of them, and all of them have 6 hydrogens. So who can tell me in the chat what name is given to those compounds? They are many, but all of them have the same number of carbon atoms, the same number of hydrogen atoms, the same number of chlorine atoms. Which name can we give them? In that their structures are different because even their names are different. But when we condense, their molecular formulae or the molecular formula is the same. What name is given to those types of compounds in chemistry? What name is given to those isomers of chemistry? There are many. The molecular formula is the same. But when we draw the structures, they are different. You get the point? Yeah, people have it in the chat. And thank you for being sober up to this time. This is what we usually do. You should be ready. That's what we usually do. Yeah. Okay. Now, should be aware this is what we usually do. These ones are always long, and this way they are going to be longer. But you should appreciate in that when I happen to get lost out of the blue, you're left with a very good foundation, and you cannot be lied to by anyone as far as chemistry and science at large is concerned. So those are what we call isomers, as you've said. So I'll come and say that the above are isomers of C3H6Cl2. And this was UNEB 2024 Chemistry Paper 1, number 10. Someone may be like, but that is old curriculum. Yes, a question of old curriculum can be turned into a scenario. Yeah. So after that, I'll give you my assignment here. I'll give you my assignment. And I'll say generate the structure formulae. So generate the structure formulae of all possible isomers I usually waste a lot of time on nomenclature because I know what it can do. Of all possible isomers of this, you can be knowing a lot of organic chemistry, but the nomenclature can put you off. When you know how to deal with structures, you can do it, but the naming, if you don't know the naming, then it can really bother you and torture you and cost you at one moment. So please befriend them. So generate the structure formula of all possible isomers of that and write the IPAC names. So I'll be happy to see this in your booking groups and the premium groups. And their IPAC what? Their IPAC names. Yeah, that's the simple number. So you all know that physical properties, you're supposed to go and write them on your own. So the lesson is done. Yeah. So physical properties, I just guide you on what to do. Then you go and make research. The physical properties are the usual ones. Physical properties, I always give them to you, and they don't change. They never change. We talk of the physical state, we talk of the solubility, boiling and melting points, the density, they don't change. So you can make your own notes concerning the physical states. You just even use internet. And these ones are not so serious. Solubility. Just use internet, make your own notes. Then after I talk about the density, there are books that differentiate boiling points from melting points, which is also very okay, not bad. But some books combine them, which is better. So you look at the boiling points, stroke melting points, boiling points, stroke melting points. So what you're supposed to do, you're supposed to make a write-up. Make a write-up and present. Make a write-up and present. Make a write-up and present. That is about the physical properties. Yeah. Then after that, you all know that laboratory preparations I always give you hints. Yes, I always give you hints, so those ones shouldn't bother you. Those ones we shall see in the next lesson. The good thing our organic chemistry almost got done, and you've seen that. So I'm not going to overstress you, because as I give you the hints, they have a lot of chemistry in them. People may get confused. So the other thing I never do, this is obligatory task. Obligatory means you're supposed to do it as a student. Of course, you cannot task a teacher, so no need of saying obligatory task for students. The mere fact that it is a task, that means it's for the student, the trainee. So obligatory tasks, that is the rules, stroke applications. They can use uses. This time around they added on ethical considerations. Now this is what I was telling you. So when you're reading applications and they tell you bromomethylbenzene is used here, you know. When they say bromocyclo everything, you know where those things are. So you know what to do. Rows, applications, and uses of alkyl halides. So here, use internet. Use the internet and make notes. Use the internet, you can even use AI. It's becoming better and better to make your notes for that, and you're done. Then, this is assignment. This assignment. I want you people to give me the IPAC name. I want you people to give me the IPAC name of this. Want the IPAC name of that. Also the IPAC name of that. Then also give me yes, you can struggle and see whether things will come out. Yeah, struggle with those and also get others. Repeat. So you're supposed to also repeat the number done by the tutor. So those examples I've been doing, you're supposed to repeat them on your own. Those compounds I've been naming on my own, you're also supposed to name them. You're supposed to name them before you can even come and do this. Yes. You revise everything and rewrite. Yeah, then lastly, okay. Hope you've been following. So lastly, the directions. The directions of the video of identifying the functional group. Directions of the video of identifying the functional group. Of course, I mean the function one. I told you that that video is already recorded and uploaded, so it's just a matter of going there and revisiting it. I told you I will never repeat myself as far as identifying functional groups are concerned. So I told you, you just come to the drive. Where is it? It's here. Hope you can see it. So I think it is still under organic chemistry. I told you when you go to the principal chemistry folder, then senior 5 chemistry, then revision and e-library, then organic chemistry, then organic chemistry facilitation. So that first video you find there, the one of an identification of functional groups, that's the video. Yeah, so we shall go back and I give you the directions. Yeah, it's present on the drive. So you go to principal chemistry. So you can take a screenshot after the directions are done so that you follow up later. So principal chemistry, from principal chemistry, go to senior 5 chemistry folder. I think this one is also principal chemistry folder. After that, you go to revision and e-library. After revision and e-library, you go to organic chemistry. After organic chemistry, you go to organic chemistry facilitation. Go to organic chemistry facilitation. Organic chemistry facilitation. Then you watch the video. Yes, then you watch the video. Yeah. So with that, you please allow me sign out. Yes. And I remain as Paul tutor, a science math tutor. So I want to see those people who are still sober. You thank me for the lesson. If you people are still awake, very lazy candidates. How can you sleep as we are looking for marks? Yes, if you want to reach out personally, that's the number, and WhatsApp calls are better. So those people are on, please thank me for the lesson. Wake up and thank me, close Zoom, you sleep. You're going to wake up when Zoom consumed your data and you never attended, and you feel bad. WhatsApp calls are better, but you can text. Calls are better for faster response. Otherwise, thank you for attending. So lastly, we always stick our targets. So things concerning the introduction, we are done. Functional group covered general formula, covered classes, sources, occurrences, and formats. All those things have been talked about. Structure, nomenclature, isomerism I've talked about. Physical properties, you know what to do. Laboratory preparations, I've told you I'm going to combine them with chemical properties. Identification, I've given you directions. Applications, I've given you hints. That means we have only 2 things remaining and they can literally be handled. Yeah. So at least we have covered 95% of the lesson targets and it is nice. Yes. Yeah. Otherwise, bye. We meet next time. Yeah, I had to stay on to first read your messages, but it is only Diana who has given me very good messages. Yes, Diana's prayer has been the best. I don't know if Chimboa is still on. Chimboa, you inbox me for the workbook so that people can have a look. But those who want to take screenshots, let me give you that chance. Is 1 second per screenshot. 1 second per screenshot. You take that so that even people who will be listening to this in the future can have that time to take the screenshots. So you take the screenshot. Hope you're done. That is 1. Take that one too. Take that screenshot too. Take that one too. But please, people, read. These things, yes, you can understand, but that is appreciating. But you need to sit down and repeat them on your own for you to master them. Another one. 1 second. 1 second. 1 second. Please read these things and master them. That one. Okay. Then this. That research of occurrences and sources, use the internet, make your own notes and proceed. Yeah, we talked of structure, IPAC and isomers. You take that. Take that. Someone who is taking the screenshots, after, share them everywhere. Yes, share to premium groups, share everywhere. In the groups of your friends. We talked of this naming, it was fun and a bit disturbing, but I gave you the strength. You also take a screenshot of that. So take that. We lost the other structures. I don't know whether someone took them. But we just need to play the video back a bit and check which work was there. Where I told you to revise again, repeat what I did, those weird IPAC names, yeah. Then lastly, that and that, the directions, then I signed out. So you people, finally, bye. You rest a bit, we resume tomorrow. Ensure to make notes, I repeat. If you don't make notes, you will not change. Please, please and please, make notes. Otherwise, bye-bye and may God bless you.